Il giornata è taiba. Well, that's the way we say hello in Malta. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, here we are talking about a topic of class 11 and 12, that is permutations. Permutations are arrangements, or in other words, in permutations or in arrangements, order is something which is very important. So if you change the order, then the number of permutation changes. For that matter, let's say we talk about a number which is, say, 1 2, and if we change the order, it becomes 2 1. So as such, the same objects have been used, but when the order has changed, then the permutation or the arrangement has become different. So when we talk about permutations, you have to remember one entity very importantly, that is, we talk about the order specific entities, right? And also remember that when we talk about permutations, these are actually arrangements that we are talking about. So this is a synonym which in times to come you will get to use. So in certain questions you will be asked to find out the number of arrangements and not to find out the number of permutations. So there is nothing to be ambiguous about. You just have to understand that this is the number of permutations that you have to find out. Now remember, children, if suppose you have n objects and you got to find out the number of permutations taken r at a time, that means n is a larger number and r is a smaller number, and given n objects, if suppose r objects are taken at a time and you have to find out the number of arrangements, then it is given by npr, right? So here we can have an example of this. Let's say we talk about this to be, say, some 10p3, which is to be found out. So here we will have some 10 objects, out of which 3 objects are taken at a time, and if the number of arrangements are required, then you talk about this to be 10p3, right? Now how do you calculate this? So this is written like n factorial, which is divided by n minus r factorial. Or in other words, here we will have the factorial of the number which is there in the superfix divided by the factorial of the difference of the numbers in the superfix and the suffix, right? So if we talk about 10p3, again this is going to be written like 10 factorial, which is going to be divided by 10 minus 3 factorial, further to be calculated as 10 factorial divided by 7 factorial. Now if say we talk about 7 factorial, then 7 factorial is what? It is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1. That means whenever we talk about the factorial of a number, it is actually the product of the number with one number less than itself, right? And further it is then multiplied with another number less than it, and all of this continues up to 1. Remember, whenever we find out the factorial, it is always that of a natural number value, right? And the factorial of a negative number is 0. That means if suppose we want to talk about factorial of minus 4, then that is 0, right? And if we talk about factorial 0, then factorial 0 is given to be 1. So these are two values also you require to remember, right? Now quickly repeating all of this. Now if you have some npr, that will give you the number of permutations or the number of arrangements which are order specific, right, out of n data when r data are taken at a time, right? So here then that becomes equal to factorial of the number which is in the superfix divided by the factorial of the number which is the difference of the numbers in the superfix and the suffix, right? Now if we require some 10p3, that will become equal to 10 factorial divided by 10 minus 3 factorial. So that will become equal to 10 factorial divided by 7 factorial. Now 7 factorial can be written as 7 into 6 into 5 into 4 into 3 into 2 into 1, right? And these values, when you substitute, you will be able to further calculate it. For that matter, I'll help you in calculating of this. So we can write this to be 10 into 9 into 8 and further multiplied by factorial 7, because this will go from 7 into 6 into 5 into 4 into 3 into 2 into 1, which is actually factorial 7. And as we have a factorial 7 in the denominator, both of these will get cancelled, right? As such, then you will have 9 to 8, which is 7 2 multiplied by 10 will become equal to 720, which will then become the final answer, right? So this is how, children, you find out the number of permutations. Let us now quickly have a sum on notation, so that if such sums come your way, then you're able to solve them with ease. So this, children, is the question that I have for you people. Now we will quickly discuss this. In the question, we've been given that we have some 5 times of 4pn, which is equal to 6 times of 5pn minus 1. So here what we do is, first we talk about the notation that we have at hand. That is, when we talk about some npr, right, then that becomes equal to n factorial, which is to be divided by n minus r factorial. Whatever formulae are applicable, make sure to write them in a different colored ink so the teacher understand that this is the formula that you applied. Now after this, now children, we are now going to substitute values in this equation that we've been provided, and then we've got to find out the value of n. So this then becomes equal to 5 times of factorial 4, which is divided by 4 minus n factorial, and further on the right hand side you have 6 times of 5 factorial divided by 5 minus n minus 1 in brackets factorial, right? So here, children, next what we do is we get to see that if 5 gets multiplied with factorial 4, then it will become equal to factorial 5, which we have on the right hand side, and thus they will get cancelled. And then in the denominator we have factorial of 4 minus n, which can be written as factorial of 5 minus n plus 1. Then we will have minus n and minus 1, and 5 minus 1 will become equal to 4, right? If we write it this way, obviously both these numbers are the same. For that matter, what I want to say is, if you talk about 4 minus n, obviously that is going to become equal to 5 minus n plus 1, where this horizontal line is actually the horizontal bracket, right? Which I'm sure you must have learnt in bod mass. So as this becomes equal to 5 minus n minus 1, so that will become equal to 5 minus 1, that is 4 minus n. So both of these are the same. As such, if you find out the factorial of both of these, then they will also be equal, and that is what has been done here. Now next, in the right hand side, we will now have 6 times of factorial 5, which is divided by factorial of 5 minus n minus 1. Now children, here factorial 5 will get cancelled from both the sides, right? And then we will solve the rest. So now we have 1 upon factorial of 5 minus n plus 1, right? Which is equal to 6 upon factorial of 5 minus n minus 1. Now can you tell me which is a larger number out of both of these? Yes? Now this number is the larger number, because from 5 a lesser number has been subtracted. As such, the difference will become more, right? I'll give you an example. Let's say we talk about factorial 6. So factorial 6 will become equal to 6 into 5 into 4 into 3 into 2 into 1. Now we can obviously write this as 6 into 6 minus 1, right, which is further to be multiplied with 6 minus 2, which is further to be multiplied with 6 minus 3, further to be multiplied with 6 minus 4, right, and further to be multiplied with 6 minus 5, which is the last number. So I'm sure you will agree that both of these are the same, because when you subtract from 6 1, you will get 5. When you subtract from 6 2, you will get 4. When you subtract 3 from 6, it will become 3, and so on. Now here, children, you get to see that if we talk about 6 minus 1, then it is larger than 6 minus 2. And what has happened here is 1 is a number which is lesser than 2, or in other words, we can say that 2 is a number which is lesser than 1. So when from a number we subtract a number which is less, then the number becomes more, right? So here 6 minus 1 is greater and 6 minus 2 is larger, right? I'll just quickly repeat what I said. I said this, that when from a number you subtract a larger number, then the number becomes less, right? So similarly, children, here we get to see that n plus 1 is going to be a larger number and n minus 1 is a lesser number. So when a larger number is subtracted from a number, the number will become less. Or in other words, factorial of 5 minus times of n plus 1 will become lesser, and factorial of 5 minus times of n minus 1, right, will become greater, right? So thus we have the factorial of a lesser number, which is equal to, on the denominator of the other side, factorial of a larger number. Now let's write the next numbers which are possible. So if, say, we talk about factorial of 5 minus n minus 1, let's say now how we get this in terms of numbers up to 1. So now we can write this as 5 minus n minus 1, which obviously is going to be the first number. Now next, as you saw in the last case, we will just be adding 1 to the number which is subtracted, so that we get the next less number. So now that will become 5 minus n, as after n minus 1, the next larger number will be n when 1 is added to it, as minus 1 plus 1 will get cancelled. Now children, after this we will now talk about the next number which requires to be multiplied with this, that is 5 minus a number greater than n. So that will become n plus 1, right? And all of that will continue up to 1, right? As such, now children, we can write this as 5 minus times of n minus 1, which is going to be multiplied with 5 minus n, and further as all of this continues up to 1. So thus we can say that it will be the factorial of 5 minus times of n plus 1, right? So now we write this to be factorial of 5 minus times of n plus 1, right? And thus these values now we will substitute. So here on the left hand side, children, what we have is we have 1 upon factorial of 5 minus n plus 1, right? And on the right hand side, children, we will now have 6, which is going to be divided by 5 minus times of n minus 1, and then further we are going to multiply this with 5 minus n, and then further we are going to multiply this with factorial of 5 minus times of n plus 1, right? So further here we get to see that factorial of 5 minus times of n plus 1 will get cancelled from both the sides, right? As such, now we will just be left out with simple numbers which are 5 minus n minus 1, right, times of 5 minus n, right, which will become equal to 6. Now we just require to multiply these numbers. So in multiplication, now we have 5 into 5, which will become equal to 25, and then we'll have minus 5n, and then further we have minus 5 times of n minus 1, right? And then we have minus minus plus n times of n minus 1. That will become equal to 6, right? Further now we solve this, so this then becomes equal to 25 minus 5n minus 5n plus 5 plus n square minus n minus 6, which will become equal to 0. Now here first we will write the quadratic term, that is n square. Then we will write the linear terms. We have minus 5n, that will become minus 10n, and minus n, which will become equal to minus 11n, and to that we will add the constant. So we now have 25 plus 5, which is 30, and 30 minus 6 will become equal to 24. So we have plus 24 here, which is equal to 0. Now children, we can write the product of the prime factors of the coefficient of the quadratic term and the constant term. So that becomes equal to 24 into 1, and then we can write that as 2 into 2 into 2, which becomes equal to 8 into 3, which is the product of the prime factors. Now if we take 2 into 2 into 2, that is 8, and then the other, if we take as 3, then the sum of 8 and 3 will become equal to 11. So thus we have n square minus 8n minus 3n plus 24, which will become equal to 0. Now children, next what we can do is we can take n to be common from the first two terms, so we have n minus 8 inside, and now when we write n minus 8, this will go minus 3 times, and then it will give us minus 3n plus 24. Now out of the two terms we can take n minus 8 to be common, and then we have n minus 3 remaining inside, which is equal to 0. Now once when we apply the zero product rule, we will put n minus 8 to be equal to 0, and then n will become equal to 8, and at the other time n will become equal to 3, right? Remember here children, if you talk about the superfix, like I told you, the superfix always requires to be larger than the suffix. So as the superfix is 4, we can't take the value of n to be 8, and thus the value of n which is going to be taken will be 3, right? So this will then become your answer. Now children, I'll just quickly discuss this all over. In the question, you've been given here that you have to find out the value of n if 5 times of 4pn is equal to 6 times of 5pn minus 1. Now remember children, these are binomial coefficients like NPR, whose value is given by factorial of n divided by factorial of n minus r, right? So using this formula, now next what we do is we will now talk about putting this up on both the sides. So we have 5 times of 4 factorial divided by 4 minus n factorial, which is equal to 6 times of 5 factorial divided by 5 minus times of n minus 1 factorial. Now next children, what will happen is, as we find that 5 is getting multiplied to factorial 4, as such it will become factorial 5, which will get cancelled from both the sides. And then children, here what will happen is you will then have 1 upon factorial of 5 minus times of n plus 1, which will become equal to 6 upon factorial of 5 minus times of n minus 1. Right? So next, now we discussed one thing, that if you talk about factorial 6, it can be written as 6 into 5 into 4 into 3 into 2 into 1, right? As such, this 5 can then be written as 6 minus 1. Then this 4 can be written as 6 minus 2. This 3 can be written as 6 minus 3. This 2 can be written as 6 minus 4. And the last 1 can be written as 6 minus 5. So these are actually how you can write the factorial of a number. And here you get to see that if you talk about the first number, it will be the number whose factorial you are finding out. If you talk about the next number, it will be from 6 when you subtract 1, right? And then when you talk about the next number, from 6 you're subtracting a number greater, right? So as such, this number 6 minus 2 is lesser than 6 minus 1, and as such you are going from a greater number to a number less to a number less, and so on. And here we get to see one thing more, that if you subtract a greater number, then the number becomes less, right? So similarly here also, if you talk about factorial of 5 minus n minus 1, the first number will be itself, then the next number is going to be one number which is lesser than it, and that you can find out by adding to this n minus 1 a number greater, like we saw in this case. First was 6 minus 1, then to 1 we added one more, that is 2. Then to this 2 we added one more, that is 3, right? So here also we are going to do the same, that is the next one which is going to be subtracted is going to be n. Then the next one which is going to be subtracted will be one more, that is n plus 1. And obviously if you talk about the next one, it will be a number which will be greater than it, that is we will have the next number to be 5 minus times of n plus 2, right? And all of that will continue up to 1. So now children, you get to see that if you talk about the product of these two numbers, that gets multiplied with the numbers from 5 minus times of n plus 1 up to 1, which will become the factorial of 5 minus times of n plus 1, right? And this is how thus you can write factorial of 5 minus times of n minus 1, right? Now children, here we get to see that we can write this value that we've just found out, and we will have factorial of 5 minus times of n plus 1 getting cancelled from both the sides, and thus 6 can be written to be equal to the product of both of these, right? And further then what will happen is we can now find out the product. 5 into 5 is going to become equal to 25. Then we have 5 times of minus n, that will become equal to minus 5n. Then we have 5 times of minus times of n minus 1, so that will become equal to minus 5 times of n minus 1. And then children, next we will have here minus minus plus n times of n minus 1, which will become equal to 6. Now further we expand this, and then we have first the quadratic term which can be written, that is we have n square, and then we add up the linear terms, and then we get minus 11n, and to that then we add here the constant, which comes to 24. Further children, we factorize by writing the product of the prime factors of the coefficient of the quadratic term, which is 1, and the constant term. So the constant term is 2 into 2 into 2 into 3. This is the product of the prime factors, which comes to 24. Now we can write this as 2 into 2 into 2, that is 8 and 3. So we have n square minus 8n minus 3n plus 24. Now out of the first two, we can take n to be common outside, then we are left out with n minus 8 inside. And now when we write n minus 8, this will go minus 3 times, which is equal to 0. Now out of this binomial, we can take n minus 8 to be common outside, and then we are left out with n minus 3 inside. Now when we apply the zero product rule, we will have the value of n to be either equal to 8 or equal to 3. Now why is it that we can't take 8? That is because whenever we have a coefficient which is, say, NPR, which represents the number of permutations or the number of arrangements which are possible, then the superfix is always larger than the suffix. So here, as we are talking about 4pn, so n requires to be lesser than 4, right? And if we require n to be lesser than 4, then it can only be possible if the value of n is 3, right? So this is the reason why we keep the value of n to be 3 to be our answer. So is this clear with everybody? Sure? Really? That's good, children. Now I expect you people to practice all of this so that if sums of this type come, then you're able to do them with ease. Bye children, have a nice time. Bye.